Hey Peter, what are you up to?
Hi. I am getting ready to use the Curie Balance, which is this brand machine over here. The Curie Balance lets you measure the temperature at which your sample becomes paramagnetic. It lets you measure the Curie temperature of your sample. This is the temperature at which your sample loses all ability to become permanently magnetized in the absence of a field.
Okay.
The way it does this is you load your sample on the end of this glass rod here and move the oven and magnets over the sample. You start to heat your sample in the presence of the magnetic field, and when that magnetic field is turned on, the sample is drawn into it. As the sample is heated, it swings out of the magnetic field because it becomes less and less magnetic. And you measure the distance that this rod is swung by this device on the end, which is called a linear voltage distance transducer. That's this stalk on the end here.
Does that actually transduce a voltage?
Yeah, there is the wires here at the edge of the LVDT wind all the way around here and eventually go up to this voltmeter, which is the voltage that you record on this computer. So the voltage is related to the distance that the rod has moved, and which is in turn related to the magnetization of your sample. So to do this, you take a sample like I've got here, and your sample has to be between 30 and 80 milligrams. You clean it off. I've cleaned this one off with alcohol. And you put it in a little glass tube like this. You hope that the sample fits. Pull the cotton from them. And you drop the sample in here. Make sure it's at the bottom. And then you open up the case here. You have to load the sample in the glass tube on the end of the glass rod. There's no tape, no vacuum grease, no nothing. You just put it on there. Just attach it by sheer friction.
Yeah.
You have to do that while not breaking these glass fibers. So it's a little bit, it's not very easy. It would have been really embarrassing if I had broken the glass fiber. And then you make sure that the sample is on straight. You can tap this glass rod with the back of the razor blade to get it to swing a little bit, and that aligns it a little bit better. I've got the front end of the rod lined up with the oven, and I'm going to check it again just to make sure as I roll the oven over the sample. Looks pretty good.
Now, which part of that is the magnet and which is the oven?
This is the magnet. These black things are electromagnets.
Yeah.
And the oven is here. It's actually only the very center of this thing. The white part is the oven. And then this part cools the outside of the oven. And then you close the door. The door is to keep noise and wind from getting at the apparatus. And so you manually set the set point of the oven to 30 here. And you can see, if you film down here, the oven is starting to heat a little bit. And then you tell the computer what temperature you want it eventually to go up to, and we can go up to 650 degrees. The heating rate in degrees per minute is 30 degrees per minute. That's usually what I use. And then you turn up the current on the magnets. And And so you're starting to produce a magnetic field. And you do this very slowly. So before we start the run, we have to wait for the temperature here on the temperature controller to get up to 30 degrees C. You have to wait for everything to equilibrate. And you'll see on the screen in a matter of seconds a graph showing this is actually distance that the glass rod has traveled, but it's essentially the same thing as magnetization. And this is temperature. And it'll start recording momentarily. Abracadabra. Here we go, there's a point. It's at 32 degrees already, so there should be 3 points, 4 points, 33 degrees. So there's a line starting over here.
All the way up to 650.
Yep, and it's gonna look kind of like this. It's gonna go along here, decrease, 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 drop off at about 580 degrees, and then just decrease very slightly here up to 650.
And now you can see a little bit of the line.
Yeah, it won't look like much for a long time.